Hi, stats folks. So today we're going to look at 9.3. We're not going to do the whole thing. We're just going to look at a very important statistic that can be calculated dealing with linear regressions, and that's called the coefficient of determination, and it's r squared. I mean, we're familiar with r being the correlation coefficient. When we square that, we get something called the coefficient of determination, which is the ratio of the explained variation to the total variation. So what it does is it looks at the points that we have, it looks at our regression line, and it looks at what our predictions, our y-hats are. And I'm not going to get into all the details, but what it does is it compares how much of the variation is explained because of our linear regression and the points that we have, to how much of the total variation that there is in the situation here. And it's a really helpful thing to find because it gives us a little bit of an explanation on some things that we can say. So for example, if the correlation coefficient r is 0.9, then r squared would be 0.81, right? If I take 0.9 and square it, I get 0.81. How do we interpret that? And that's what's really nice about this, is it gives us a really nice interpretation. Okay? If r squared, the correlation coefficient of determination, is 0.81, we can say that 81% of the variation in y, in the y values, can be explained by the relationship between the x and y. Okay, so it gives us a pretty good statement there. 81% of the variation in the y can be explained by the relationship between x and y. And then on the other side of it, the complement of it, is that we've got 19% of the variation in y is unexplained, and that could be from sampling error, just randomness, coincidence, or some lurking variables, which we've talked about in the past. So what I'm going to do in this video is I'm going to look back at two examples that we've already done before, but now we're going to talk about the coefficient of determination. Okay, so remember our chirping crickets. All I did was take a picture of our work from a previous video here. Okay, we found our linear regression. We have this equation for y hat, for making predictions. Okay, we did that here. Okay. Now this was a screenshot from my calculator of finding that linear regression. Y equals ax plus b. There's the a, there's the b. We ignored the r squared and we just looked at the correlation coefficient of 0.95, and we said that's strong correlation. That's positive. Okay, so it's sloping upward. It's really close to 1. That's a strong correlation. Okay. Now, whether that correlation is significant or not, we've already learned how to do that test. But right here, okay, is our r squared of 0.90. So let's interpret this coefficient of determination in the context of this problem. And I'll just type it out so that we can all be saved from my writing here. Let's see, what color do you guys want? Okay, I'll just do black. So, what was our y values on this one? Oh, I just lost it. Our y values is the temperature. Okay. So what we can say, now this is 0.90 for a coefficient of determination. We can say about 90% of the variation in y was the chirps, x was the temperature. I may have said that wrong before. Y is the number of chirps. About 90% of the variation in the number of chirps is due to the relationship between the temperature and the number of chirps. 10%, okay, so that would be the complement of the 90%. 10% of the variation is unexplained. Okay, we don't know why that variation exists, but 90% of the variation in the number of chirps is because of the relationship between the number of chirps and the temperature. That's the statement that we get to make from the coefficient of determination. Let's look at our next one. Okay, this one was dealing with gross domestic products and carbon dioxide emissions. Now, the GDP was the x, the CO2 was the y. We found this linear regression right here. When we found our AB, we looked at our R of 91.91. Again, that's a pretty strong correlation coefficient, it's positive slope, it's close to 1. Now r squared on this one is about 0.83 or 83%. So it's less than the coefficient of determination on the last problem. What's the statement that we can make here? I'll use blue letters this time. Here we go. Okay, what's our coefficient of determination? 83%. 83% of the variation in, what was our y values? CO2 emissions can be explained by the relationship between GDP and CO2 emissions. 83% of the variation that we're seeing in our y values can be explained by the relationship between the x and y's. That leaves what? 17% of the variation is unexplained. Okay. And obviously the higher the coefficient of determination is, the better, right? I mean, the stronger that statement is. Here, 83% of the variation, I still feel pretty good about that. If it gets lower, then obviously we don't feel as good about that. But there's an explanation of our coefficient of determination and the statements that we can make. Thanks for watching.